Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the last lecture, which is lecture number 15 and 16 of computer programming for civil engineers. And this lecture will be an advanced application in Python. And today you're going to learn how to load online data, how to access it through Pandas library. So this is a very powerful database library. We'll learn something useful about it today. Also in bonus, you will learn how to play sounds through Python, and the example which we are using today to learn pandas and playing sounds is this example. So what is asked, or what we are going to do today, is we are going to access the United States Geological Survey's live earthquake data, and they keep updating this data continuously after almost every minute. And whenever they discover any earthquake or record any earthquake happening anywhere in the world, they quickly update this database, and we can access it to get something to make something useful out of that information. So what we are going to do is we are going to check that database every minute using Python, and then if there is any earthquake with epicenter within Pakistan, then and that is also if any earthquake occurred within the last 1 hour, for example, within the Pakistan area, then we are going to play a siren on our computer as a warning that there was an earthquake a while ago. So let's start doing that and learn Pandas through it. Before that, let me give you a slight idea of earthquakes, so that once we access the Usgs database, we know what it is talking about. So may Allah protect everyone from earthquake hazards. But then how it happens is that a ground actually slips, as we can see here, and it can be a sheer vertical failure like this, or it can be inclined in any other direction, but let's not go in any detail of that. But what's happening is that this energy of slip is being stored about this fault line, and whenever this energy is enough to break the fault line, it just creates a sudden slip, and this energy is actually released at a particular point under the ground where actually this slip or crack starts, and that point is called focus or hypocenter. Right above that point is a point which is called epicenter on the ground. So what we are going to use today is that if that epicenter is within Pakistan, and if that particular earthquake also occurred in the last 1 hour as well, then start playing the siren on our laptop or computer or desktop, so that we get warning and then do whatever we plan to do in that case. For example, National Disaster Management Agency, NDMA, and similarly provincial disaster management agencies as well have the responsibility to get such warnings and proceed with the rescue operation. So let's go ahead and apply this in Spider using Python language. So here I've already opened an untitled file for us today, and we don't need these comments, so let me clear that first of all, and let's start by actually importing the Pandas library. And as we import any other library, we just simply write import Pandas as, for example, I can do that as PD or any other name you like to use it for. Now Panda is a very powerful database based library, and it can access several types of data. For example, if you write now pd dot read, you will see that there are several types of things that Pandas can read. It can read a CSV file, it can directly read any Excel file as well, and any sheet inside it, any table, any pickle format, SQL or SQL format. It can do SQL queries and bring its results. It can load JSON object type or JavaScript objects. It can load HDF data, HTML data, SQL tables, FWF, S data, and feather data, perquit data, MSG, pack type of data, SAS type of data, as well as clipboard and GQ, GBQ type data. So for example, clipboard is a data that is actually whatever we have copied on our computer, that is available at the clipboard. For example, let me write clipboard here, and then let me store the result in a variable called d, and then let me print that in the next line, the print d. So let me run this and see what we get. So here's some big error which says uh, some type of data is totally not available because there is nothing being copied yet. So let me write something in Notepad, for example, like my name, and now I select all and then Control C to copy, or I can go to edit and copy as well. And then now if I run this code, so you will see in the result it says that the data frame is empty, but it has a column named Adil, and index is blank. Now what does it mean? In order to understand that, let me create a table out of this. So for example, if the first column is serial number and the second is name, and then for example the third one is class, I have separated them with a space. So in the next line, if I say serial number 1 and the other I say 2 and then 3, and then with the space I write the name as Adil and then the class as first, and then in the next line I write Muhammad and then Sallallahu Alaihi Wasallam and then second, for example, and then in the third I write Asad, and then with space I write, for example, fourth here. And now if I just copy it, I selected all like this, and then I said edit and then copy or Control C, and now just simply run this code here in Python, you will see that automatically it has been understood as a tabular data. So what happened is that first row here has been considered as the name of the columns, and then whatever comes underneath is being added in that column. So you can see that first row is the row of column, names of the columns are called fields, and then all the entries there. What's different is 0, 1, 2 is the index automatically given by Pandas to it. Now why it was blank or empty data frame earlier? Because there was nothing provided earlier. I just copied ADIL only. So the it was thinking that the first column name is ADIL, while in this case the first column name is serial number, second column name is name, and the third column name is class. So once it was just empty like this one, it was just written there before in the previous case, so it thought that that is the name of the first column, and if you see there is no entry below it in the data, so its data frame is actually empty. As you can see here, it says data frame empty. So all table, a full table is known as data frame in Python. So in Python, Pandas. So instead of storing it in D variable here, just to give it a more understandable name, I can call it data frame or simply DF, in order to make it more understandable that actually whatever we acquire from anywhere and use in Pandas, that thing is called data frame, and then we play around with that data frame to achieve something out from it. So currently what we want is, we want to go to Usgs website, we want to capture the latest last 1 hour earthquake data, and then we want to play with it so that we know has any earthquake occurred in Pakistan or not, and if it is, then we want to play a warning siren about it. So in order to achieve that, let's go to the Google website, and then here let's search for USGS earthquake CSVs, for example, because we are interested in CSV form. There may be other forms of data provided by USGS, but then I search for CSV only. But we have just seen the list a while ago that Pandas can read several other types of formats. Like one of them we used was clipboard. In fact, if now from this browser I just copy anything, Control C, and in Panda, if I just run it now in Spider, so you can see that whatever I copied with spaces has been considered as the title of the um, database, and everything is empty below it. So just to elaborate this example further, let me search for floods in Pakistan, and then I go to, for example, this link of floods in Pakistan, and then if I see any table here, I can't see any. So maybe in 2010 here, for example, if I go there and down here, yes, there's a table here. If I go ahead and select this table and simply say Control C or right click and copy that, both are same thing. And now if I run this clipboard and print data, let's see what we get out of it. So it gives us an error and it says that expected field numbers are wrong actually. So let me go in Notepad and delete all this and paste all data and see what's wrong with this. So notice that first field title is city, and first row is also blank, so let me delete that row. Then after city there is a tab, and then after tab there is rainfall and space. We don't want spaces here, so why not I go in edit, replace, and wherever we have space, I write space here. I want to replace it with underscore, for example, and I say now replace all. So and I close it. So now you can see that wherever there was a space, it is replaced with an underscore. There was also space in Khyber and Pakhtunkhwa and Islamabad capital territory, so all of them are now replaced. So it seems a perfect data now. Let me Control A, select all, and Control C, copy. And now because it is in the clipboard of the computer, let me run this code and see what we get. So now this data has been read perfectly as we wanted. So it is showing us the first two columns and the last two columns of the data, and all of the internal is not shown here, but just ellipses are shown that there are so many other columns in it. So this is a quick way of for Pandas to show us the data. So clipboard is perfect, but then let's go back to our today's case where we are actually interested in getting USGS earthquake data. So I go back to my search, and here is a link of spreadsheet format of USGS earthquake hazard program. If I click it, it will take us to USGS website, and in spreadsheet format here I find something very interesting, that for past hour updated every minute, and then past day updated every minute. So if I bring my mouse over this significant earthquakes and see in the bottom left here that it is actually a CSV file. Excellent. And this is only those earthquakes which are significant, but these are the ones with magnitude 4.5 and more. These are magnitude 2.5 or more. These are magnitude 1.0 and more, and these all earthquakes in the past 1 hour. But for us, we decided that we'll use the past day. Actually it is much better program if we want to give a warning to use as latest data as possible. But in past day all earthquakes, we will already have the data that includes the past 1 hour as well. So it's no problem in using this data as well. So if I bring my mouse over all earthquakes around the world, I can see that it is also a CSV file. So instead of downloading it, I can actually right click it and I say copy link address. Now the link of this file is copied, and now I can go in Pandas, and instead of now storing the data frame of the computer copied data, I just say dot read, and then this time we know it is a CSV. We know it is CSV, so I say underscore CSV, and then if it is on our computer we can simply write the path here in quotation mark, but we know it is from the website, so we just simply paste the link you just copied, and we know already it is a CSV file. And now we are asking Python to print this data frame for us. Let's run it and see what we get. So it's connecting to the internet, and then here it is. We have some very interesting data, and it says that it has the first column of time, second of latitude, and so many other columns, and then the last two columns are location source and magnitude source. It is coded in a form. Time is according to the time zones, and then there are rows and rows and rows, and then there are so many rows in between, and then the last few rows are these. Okay, and here it also tells at the end that there are 279 rows so this means in the past one day around the world 279 earthquakes have been recorded of all magnitudes. And then there are 22 columns, so about those earthquakes there are 22 information, like number one is time, number two is latitude, and so on. And again automatically they have been indexed by Pandas in the first as it appears in the first column here, from 0 to 278, so total 279 rows. So excellent. Let's try to capture some useful data out from it. And in order to get a particular set of column, let's go and check in the website by Usgs that what kind of data they provided us. So here they are telling us the first two columns are actually time and latitude, and then the third will be longitude, depth, magnitude, and so many other things. And as before, the last two columns were source and then some magnitude information there as well. Let's get only useful columns out from it. We don't need all of them. So what we are interested in now are in perhaps place, so and also the magnitude of the earthquake, which is MAG. And let us first of all see what actually is in that particular CSV file. Beside this, note that there are also past 7 days and past 30 days data as well, but these databases will be very large, but they are also updated every minute. So this past 30 days database of all earthquakes will also have all these data, but we are not interested in that. Perhaps this is enough to create a warning. But then we downloaded this, so let's click on this and then download this file. Let me store it here and then in this folder, and then see what's inside this file. So let me open the file. So as it was shown by Pandas that there are 22 columns, let's double check that. So 22 columns. So let's go back in Excel. Now you can see that these are not they are comma separated values, but actually Excel, this version of Excel is interested in semicolon or tab separated file data, but actually we can convert it. So all this data is actually shown in one column only, column A, and column B and C and D all are actually blank columns. So let's convert them into all into proper columns. We know it is comma separated, so let me select all this data by selecting A, and then going in data and then text to column, and then we know it is delimited not by tabs but by comma, so we go to next, and then instead of tab we select comma, and you can see now every column has been separated perfectly. So let me click on finish. So now we have in Excel a separated comma separated file clearly visible to us. And now let us see the columns we are interested in. Yes, we are interested in magnitude, and in your assignment you may also be interested in latitude and longitude in your in-lab assessment, but then we'll talk about it later. We are also interested now in place, so let's see what we have in place. So we have the information that the epicenter was actually 60 kilometer west, um, uh, west and towards in between west and northwest of Happy Valley in Alaska. So the last information here is actually the state or the country. So for example, this data is in California, and then this was in Nevada. This is also California. And if you go on further, try to fetch some other countries where earthquake happened. So here we have some information in Iran in the past 1 hour. So it's fresh data. Something happened in India as well, and Greece. So it has information about countries, but then Alhamdulillah, nothing happened around Pakistan, but something happened in Indonesia, and several stations are there in America. So most of the information is from America. Pakistan, unfortunately, is not very well instrumented, so we have very less data in that form, and that is why you can see that America is very much instrumented, so they have a lot of data. Canada is there as well, so, and then so much amount of data, and Mexico, right. So because nothing happened in Pakistan in the past 1 hour, alhamdulillah, I will be instead using this example for Indonesia, for example. So we'll capture all the earthquakes in Indonesia instead of Pakistan, just to demonstrate that what happened, and we'll create a warning siren out of it. So now we have understood the CSV file, and we know now that we are interested in place and magnitude of the earthquake. So there are so many other columns there too, but we are not interested in them currently at the moment. So let's pick these columns up. So back in Python, so here I just asked Python to print whole of the data frame, and we got all the data out of it. But currently we are only interested in place and magnitude. So here now I'll say that from the data frame within box bracket, and in the code I'll say place. Now let's run this code and see what we get. It's connecting to internet, and it got all the data about place, but let's also get magnitude with it too. So let me write comma, and then in inverted quotation marks I'll write MAG. Make sure your spellings are same as in the actual data. We have just noticed that these were the spellings used there. So let me run it again. Now if we want to get a single column, we'll use of a data frame, we'll use a single box bracket. But then if we want multiple columns, then actually out of that big data frame, which is this one, we are actually getting a smaller data frame, not just a column. So here, if once I wrote only place, I got one column, which was okay. So with single box bracket, we can get single column only. But in order to get a data frame, for example, not one but multiple columns, which becomes a data frame itself, we have to close it in double box bracket like this. So let's run it again. It's connecting to internet, and here it is. We have now place and magnitude. So we have learned that in order to get only a column, we use single box bracket, but if you want multiple columns, it is not getting a column, but it is getting a data frame of 2 columns. So we have to write 2 box brackets and write everything within it. Excellent. So we have filtered out only 2 columns that we were interested in. So let's move on. Let me store all this information in a variable which is required data frame equals to df, and then I'll simply delete this part here. And then move to the next line. And now just to be sure, I'll just simply print required data frame and see what we get. We should get the same result once again, connecting to the internet, and here it is, the same result. Okay, now let's remind us what is our task. We want to capture Pakistan, but then we just noticed that because nothing is available about Pakistan yet, so we've discovered that it is available for Indonesia. So I'm just changing the concept here, and then we'll talk about Indonesia now. So we'll capture now that if anything happened about earthquakes in the past 1 hour in Indonesia, and that earthquake is having a certain magnitude greater than some value, then start playing a siren on our laptop or on our computer so that we get a warning about it. So let's try to capture Indonesia out of it. Now, in order to do that, let me print something here. So if we want to, so if we first of all want to capture all those rows where we have a place that contains the name of the country as Indonesia, just select those first of all. So let me write here that contains country. So I'm just making a variable equals to, now I'll say required data frame that we already had. Now we know that there are two columns in it. One is called place and other is called magnitude. In place, we want to see that does it contain Indonesia in it or not. So I'll say dot place. Now if I want to search something in magnitude, I will write dot mag, mag. But in it, I'll say dot string, that in place, when there is a string, then in that string check that it contains what. In quotation mark, I'll write Indonesia. So let's hope I've written these spellings correct, and this time let's copy this and print this on the screen and see what we get. So if I run it now, it's connecting to the internet and it got all this one column of data that tells that nothing about Indonesia place in first row or zeroth row, nothing in the first, nothing in the second, third, fourth, and nothing at all. But maybe there is some information here in between which is missing, and it may have Indonesia in it. And as we noted in the actual data in the CSV file, Indonesia was somewhere in between, so it is definitely there, but it is not showing us on the screen here. So what we'll do now, we'll apply this conditions that wherever it is false, just don't show that, remove that data, and only gather the data from this data frame, only gather the data where this column has value true. So in order to get that, we'll say data frame of country, and that is equal to required data frame. From all the required data frame, get what? Get wherever this has true. So you can see that in contain country, it has all false and trues. So wherever any row contained Indonesia in it in the place column, then that is definitely true in it. And here we are saying that in the required data frame, which is all the data here, whenever this column becomes true, just capture that data and store it in df of country or data frame of country only. So which country? Indonesia for us. So let me copy that and paste it here, and let's print this result for us. So it's connecting to internet now again, and now we have seen that out of 281 samples, by the way, we have just noted here that one more earthquake occurred around the world somewhere, so the database is automatically updated. Earlier, you might have noticed that it was showing only 279 rows, but now in our data we have 281. So may Allah protect everyone. About 2 more earthquakes occurred somewhere around the world while I was just writing this code. So now we can see that data number 110, 189, 201, 231, 248 and 254, these rows had the country named Indonesia written in it. So imagine if it was Pakistan, we would have the result could have been for Pakistan, but let me check that, why not. So I changed that to Pakistan, and let's hope nothing happened in Pakistan. So yes, we see a blank row, alhamdulillah, nothing happened. No epicenter was found in Pakistan. So let me change it back to Indonesia and run it again. So connecting to internet, and then 1 2 3 4 5 6. So 6 earthquake occurred, and we know Indonesia is on a serious fault zone around the world. So we have captured the country, and now we need to check whether the magnitude of the earthquake, say for example, is it greater than 4.8 Richter or not, for example. So if any earthquake occurred with the magnitude greater than 4.8, then we should start creating a warning for us. But if it is of a lower magnitude, then we don't need that siren or warning to run. So in order to capture that, now we know our data frame has two columns. One is place, other is magnitude. And now we are interested in the magnitude column. So what I'm going to do now after this is, from this data frame of country, let's pick the earthquakes greater than 4.8 Richter. So this time we'll get a data frame of earthquake of significant earthquake. And for us, we have decided that significant earthquake is the one where we have magnitude greater than 4.8 Richters. And here it is obvious that 3 earthquakes occurred with that magnitude. So here I'll say is equal to the same old data that we used, data frame of country we just received within for Indonesia at this for this case. And now in box bracket we'll write that what data we need. We need the one where in quotation mark mag is, then after that we'll write greater than 4.8, and let's print this database. It's connecting to internet. Sorry, it should have been written outside this greater than 4.8. So we'll get a column. It says true, false, 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 true, true, which means that this is greater than 4.8, this is not, this is not, and this is not, while the last two are also greater than 4.8 Richter. But then we don't need this true, false, and true, false. This is a set of true, false, which tells that these rows have the condition true while these have false. So what we want, that wherever it is true, just bring that data out from this data frame, and we don't need anything else. And what is this data frame? This data frame is called DFF of country. So here we are going to write from the DFF of country, get where this condition is true. So wherever this condition has true in it, it will get that row and store it in DF of significant earthquake, data frame of significant earthquake, and wherever it is false, we get rid of it. So let's run this code once again. So it's connected to internet, and now you can see only those 3 rows are available, which was row number 110, 248, and 254. So 110, 248, 250. So we are now reducing and focusing now on our required data. But now we need to judge that if this happens, what we want to do. What we want is that if it happens, then create a siren on it. But let's check first of all, will it work if we change it to, for example, 5? So we already know that in Indonesia nothing like 5 Richter occurred, alhamdulillah. So it should give us no result at the end. So let me run it again. So it is blank. So we'll not run this warning. So in the next line, what I'm going to write is, I'm changing it back to 4.8. And next line, I'm going to write rows in data frame of significant earthquakes. And how to capture that? Let me write first of all um, data frame of significant earthquake we just created in the previous line number 7, and this time I'll write dot shape. Now what it do is it gives us the size of this or shape of this data frame. So it has currently 3 rows and 2 columns. So the shape of this data frame is 3 by 2. So let's run it and get this answer. So it is telling us that this is a 3 row and 2 column result. So we can now think that if there are no rows, there is no earthquake greater than 4.8. But if there are rows or the number of rows are more than 0, this means at least there is one earthquake that occurred in the last 1 hour with the magnitude more than 4.8 Richters. So here, instead of shape, now if I want to capture number of rows, in box bracket I'll write 0, which is the 0th item here, which is 3. So let me run it. So here it is. We got the number of rows out of it, which is 3. If I want or interested in columns, I'll write 1 here, which is the 0th. After 0th is the first item. So let me run it again. So we should get a result as 2, and excellent. So now we are actually interested in 3, in the 0th item, which is number of rows. So now once we captured that, let me run it again and once see. Okay, so now what we can do is we can apply a condition to it, and the condition can be, let me give a gap for it just for fun of it. We can provide as much gap as we want vertically, but horizontal gaps are not permitted unless we want to block the code. But then let me write, if rows in data frame of significant earthquakes is greater than 0, then do what? I go to the next line, and for now I want to print earthquake occurred, and of course it should be in quotation marks. And then elif, which means else if, I create a block after writing colon again, and that is print Alhamdulillah no earthquake. So let's check it by running it. Okay, so it's giving us an error because it is asking that if what condition happens that we should do this, but we are not interested to check any condition. So instead of else if, I'll use else only. So if this condition is true, do this, but if this otherwise, just print this. But if there is any other condition I want to check, instead of else I'll write elif, which means else if. So let me run it again. So it's saying earthquake occurred, and there are 3 earthquakes actually occurred because there are 3 rows in our data. But let me change it to Richter 6, for example. We know there is no such earthquake occurred yet, so it should tell us Alhamdulillah no earthquake, and we know we also captured it through rows in data frame of significant earthquake variable. So we don't need it actually now, so it's working fine for us. So let me delete this row now. We don't need it because we are capturing that result from there. But this is not what we wanted. We wanted that if any earthquake result comes up, which means EQ occurred, we want to play a sound on our computer. So for that, there are several libraries available. You can go online and search for them, but one of them which is commonly used called play sound. So what we'll do is we'll go to Anaconda prompt, and we'll simply say pip install play sound library. Press enter for it. will take a while. I already have installed, so it's saying it's already satisfied, but in your computer it might not be there, so it will install it for us. So now once it is loaded, we can now simply come back to Spider, and this time we can import play sound as PS, and here we write that if rows in data frame of significant earthquake is greater than 0, so write this on the screen, and then also do what? Play sound dot play sound, and here we need to write the name of the file that we want to play. So instead we can, if you know where is that mp3 file that you want to play, you can give a full path to it here. I have already downloaded one, so let me get its path from here. So I just simply copy this, and the name of the file is siren.mp3. So in quotation marks I'll write the path, and then the name of the file was siren.mp3. So we know now currently in the last state it is greater than 6, so it should not play any sound, but let me change it to 4.8 and see what happens. Of course, as discussed earlier, the path file names should have forward slashes, not backslashes. So let me change all of them to forward slashes. It's always easier to save your code in a folder where you already have mp3 file, so you don't need to give path. I'll demonstrate that in a while as well. But let me run it now. So it's playing the siren and it's saying earthquake occurred. Perfect. So let me save it now. File, save as, and I save it in a folder where I can access this siren file directly. I name this code as earthquake siren.py, and I save it. So now, because in the same folder I have already saved this siren mp3 file, so I don't need to give this whole path. So let me delete this now, and let me first of all show you actually it is the case. So here mp3 siren mp3 file is in the same folder as in the folder I have saved this earthquake siren.py file. So now because both of them are in the same folder, I don't need to write that whole path. And let me play it once again with 4.8, but so it's working. Let me change it to 6 and see what it does. So alhamdulillah, no earthquake, so it's fine. So we are working up till here perfectly fine. But what we want is that, as mentioned here, well, let me change this slightly. Any earthquake, if there is any earthquake of magnitude greater than 4.8 Richter with epicenter in Pakistan in past 1 hour, if yes, play siren on computer. So we wanted actually to check it after every 1 minute. So here I'm going to introduce you with another loop which is called while loop for us. So in order to explain how while loop works, let me create a new file. So here I'll just I don't delete that at the moment, so just they're all remarked. I'll just simply say a is equal to 0, for example, and here I'll write while a is less than 10, and then I'll create a block. Do what? I'll say do print a, and then Um, well, let's do this first of all. So if I play it, you will see if, notice here, a is equal to 0. Is a less than 10? This is true. So while this is true, keep doing whatever is written in this block below it. So this means it will print a, which is 0. So it will print a and then it will keep printing a infinitely, because a will remain to be 0. And we have to stop this program by pressing Control C actually. So let's see what happens. So I run this code and see it is typing 000, it's moving next and it's continuously typing it. I go up and I cannot, it's just typing and printing and printing. It's just a infinite loop. I'll click here and press Control C to stop it, and now it says that keyboard interrupt of Control C occurred to stop this code. So because it was 0, but what I will do this time is, in the same block I'll say a is equal to a plus 1. So now it will check, is a smaller than 10? Because a is 0, it is smaller than 10, so it will print 0 and then increment a to 1, and then it will go back and then check, is 1 smaller than 10, which is true. It will print 1 and then increment a to 2, and then 2 is still smaller, so it will print it. Then 3 is still smaller, print 4, 5, 6, 7, 8, 9, and then 10 is not smaller than 10, it is equal to 10, so it is false, and will get out of this and it will reach to the end of the code. So let me run it once again. So here it is, it checked from 0 to 9, but 10 was not smaller but greater than, it was equal to 10, so it stopped there. So let me write here, so outside it, print ended. So here it's working, it's not coming to this line until this loop is completed. So now we have learned another type of loop. If you want to repeat anything in the code until a condition becomes false, you can use while for that. In one of the previous lectures, we learned for loop to create loops for us. If you are interested, you can also close this in parenthesis. It will work fine, just as before. So let's use this concept in creating a check system that checks every minute whether there is earthquake in Usgs website or not. And we have just noted a while ago that few earthquakes were actually added very recently in this database, so it actually is an active database. So let's close all this code inside that big while loop. So I'll write here while, and then I have to check a condition, and instead of checking a condition, let me create an infinite loop. I'll just simply say while true. So while true means that this condition is always true, so while this is true, just keep repeating that. But what I want is, I first of all just say tab here, because I want to repeat all this, including this, including this. This is, I'm closing that in a block. This was a block for if, this was a block for, this wasn't block of if, this is separate, this is the block of else. So now all of this will be an infinite loop. It will never stop until you click here and then press Ctrl C, only then it will stop. So let me try running it. So let's run it first. It's connecting to internet, and the no earthquake, and it's just continuous loop, and then it is keep checking and then, but it is doing it almost every second. Let me Control C and stop it by clicking here first of all. So here it is, we stopped, and then by keyboard interrupt. We decided that we actually want to check it after every 1 minute. So for that, we're going to use another library in Python called time library. So let me import the time library, import time as tm, for example. So after this, somewhere after going to the website, and then checking all this after printing and running the siren if there is any, or just printing alhamdulillah no earthquake. I just want outside it here to time dot sleep for certain seconds. So we know that if you want to wait for 1 minute, we have to wait for 60 seconds here. But 60 seconds for demonstration purpose is very large time. So let me actually write 2 here. So we'll wait for 2 seconds and then go ahead. So let me run this again, and you'll notice this time it's connecting to internet and then it's waiting for 2 seconds. Now it is slower than before. It is telling us that actually it is waiting for 2 seconds. Let's put a counter on it so then whenever we come back and check here, we know that this software is checking the earthquakes for how long. So I stop it again by Control C, and we should also be able to tell our user that you can press Control C anytime to stop it. So here after before waiting for 2 seconds, I actually write for the user print. Well, actually, first of all, let's keep a record of time. So seconds passed equals to 0. So I'm first, before starting the loop, let me store a 0 second information here, and then here we are going to increment the seconds after the delay of 2 seconds, for example. So here I'll say seconds passed equals to the same seconds passed plus 1. Sorry, because it's a delay of 2 seconds, then we should increment it to 2 seconds have passed. And before this, let me write this time. So I can say print, and then monitoring for, and then in curly brackets I'll write this name of this variable. So whenever we use this variable, we should write F, format F in the start, which means that wherever we have curly brackets, just replace that information with the value inside this variable. We need a space here just to make it more beautiful, and then after this number we should want it to write seconds, monitoring for this much seconds. And then in the next line, so I want to write press Control C to stop, but this will write it in the same line. In order to write it in the next line, we have to use \n, which means go to the next line and type this information, and here we have a gap, so it will create a space after it as well. I'll remove it after first test. So let me run it now, but first see what it will do. It will first set the time to 0, then it will start an infinite loop, go to the website and get the data, and then extract only 2 columns of place and magnitude out of it. Then in the place, it will check only if Indonesia is mentioned in any of the place column, and then it will get all those columns where it is true that place is Indonesia, and then it will create another data frame for us where from the last database where it had all country based information, which is for all Indonesia information, it will check all those where magnitude is greater than 6, and once that is set, we will get the size or shape of that and actually find out number of rows in it. And if these number of rows are greater than 0, this means some earthquake occurred in the past 1 hour. So it will print earthquake occurred and then play the siren on the screen. Otherwise, it will write alhamdulillah no earthquake occurred, and then after all this information, it will write on the screen that this software is monitoring for earthquake or at USGS website for that many seconds, and then the next line it will write press Ctrl C to stop this, and it will wait for 2 seconds. Well, in actual program we planned to wait actually for 1 minute, so here it should be 60 seconds, but just to test today we are just writing 2 seconds here. It will increment it to 2, So this should be 60 for that proper case, and then here we'll increment that 60 second have passed, but then for now let me write 2. So let's run this code and see how it works. So because we are just checking on 6 Richter earthquake, so it should not give us anything. So it's saying monitoring for last 4 seconds, press Ctrl C to stop, monitoring for 6 seconds, and it will keep printing that on the screen. So for 8 seconds have passed, and so on. So this monitoring software is ready. So let me Ctrl C and imagine that an earthquake has occurred, and we know that for the check is for 4.8 Richter, that earthquake has occurred. So imagine it was running and running and running, and it was showing all these seconds, but suddenly US website updated their information that in Indonesia an earthquake of 4.9 or some other higher value occurred, and then once they updated, our software read it. So see what happens. So let me run this code now, and it should play a siren with some information. So for 0 second, and again once the second loop will start, it will play the siren once again. So it will keep playing the siren until we stop it after every seconds of checks. So actually the audio file also plays for some seconds. Because the audio file also plays for some seconds, we should add that the second length, the length in seconds of the file, audio file here for this particular case. So here we in it we should write how many seconds have passed in playing this as well for an accurate time, and we can check that in the properties of this mp3 file. So in the details we know it is about 9 seconds long file. So here we'll add an increment of 9 seconds to it. Let me stop it from here, and here, so 2 seconds are already added here. We'll just simply copy that once again, and here we'll correct the time, that how many seconds. So among that 9 seconds actually have passed in playing the audio file, and then 2 seconds in this delay or sleep time. So now the timing has been corrected. Let me play it again once for this case. So we are seeing here, so 9 seconds have passed, and then so 18 plus 2 is 20. Perfect. Let me Control C to stop it. Once the audio will stop, I can Control C, and it's now stopped. So that's it. This was the code we wrote. If you ask any of your friends who already do programming in any other programming language and ask them to write this program, they will write hundreds of lines for it. But in Python, you can see just in 22 lines, we have written a very powerful code that can actually monitor earthquake online. In your lab today, what you have to do is the similar thing, but instead of checking the name of the country in the list, you have to check that whether the epicenter lies near the surrounding of Pakistan using latitude and longitude, and rest of the things are same. So you have to access the USGS live earthquake data to check after every 1 minute that if there is any earthquake within the epicenter, with epicenter near surroundings of Pakistan using latitude and longitude in past 1 hour, and if yes, play a siren on the computer. So if you go on any website to search for the coordinates around Pakistan, we can see that here these vertical lines are called longitudes and these horizontal lines are called latitudes. So you will check that if the epicenter, so actually in our code here we checked that is the place name contains Indonesia, but it is here we checked that is the magnitude greater than 4.8. So we'll use a similar technique of how we check magnitude. We'll use a similar technique to check that the latitude and longitudes are within this range for Pakistan, and I've given you the range here, that the latitude of Pakistan in its near surroundings are starting from around 23 to all the way up to roughly 38. So if the latitude is between 23 and 38 degrees, and these longitudes are between roughly 55, for example, and 80 degrees, then play the siren. Otherwise it is not in the surrounding of Pakistan, and don't play the siren. So good luck in your today's lab and in your coming exams. Assalamu alaikum.